Hello my dear students. Today we are in lecture number 43. Okay. It is lecture 43 of chapter 3 current electricity. Alright. So student, in last class we have discussed about the potentiometer and we study how this potentiometer work, why this deflection, a null deflection is considered in potentiometer, and how this null deflection work for potentiometer. In today's lecture we will start with the first application of this potentiometer, and the first application was to find EMF of a cell. Okay, so we are going to start our lecture from here. I don't think that the very much detailed discussion again you need in this lecture 43. Okay, this is a potentiometer AB. It is connected with a driving cell V, a cell of EMF E with internal resistance, galvanometer. Suppose this is the balance point, that is the neutral point, and what is this? This is the jockey. Okay, this is a balance point, that is the balance length X, and this is the balance point, the EMF and the internal resistance. Now student, what we discussed? We discussed the first, it was potential gradient. Okay, the first was the potential gradient. So here I am writing the potential gradient. The potential gradient you will find phi as potential across wire, the end of the wire, divided by length of the potentiometer. It is the phi is equals to VAB by L. Alright. If you want to find VAB, then simply you have to multiply this phi with L. If you want to find the potential across the very small length, then you have to multiply this phi with the small length. The very simple. Alright. Now, the few simple question we will do to find this EMF, but before that I am explaining. Try to focus over here. Student, look at here. When this IZ 0, that is at null deflection, when IZ is 0, what will be the potential drop across this resistance R? Answer is 0. If there is no current, then potential will be how much? 0. Okay. At this point, potential is E. Alright. And at this point, I hope you can see clearly, at this point the potential is how much? It is 0. So what will the potential over here? This is also 0, na? Because potential doesn't drop over the internal resistance. So it is 0. Potential over here is also 0, and potential over here is also 0. And here E, and here also E. Fantastic. By using this particular instrument, if we don't have the value of E, only finding this length where this galvanometer gives 0 deflection, you will find the value of X by experiment, and after multiplying this X, you know very well the value of this phi. After multiplying this phi with the X, you will find the value of what? You will find the value of this E, because this E and this E should be equal. We have studied in last class. To show the 0 current, both the potential should be same. So the potential over this length and potential of this cell will be what? This will be same. Remember, my dear students, in last class I have given you few circuit. It was drawn here. in which we study if this is the positive terminal connecting at this point and this is also the positive terminal connecting at this point, then only can this I will be 0. What will happen if you will flip this battery? Whether this will give 0? Answer is no, it will not give 0. So be careful while you are performing the experiment. If you have connected this driving cell positive terminal at this point, then of other cell for which you are doing the experiment, the positive terminal of that cell also connect at same point. Otherwise you will not able to find the balance length. And what will happen in experiment? Of course current will flow, but the problem will be there. If you will connect your jockey at this point, you will find galvanometer shows one-sided deflection, and if you will touch this galvanometer at the other end, you will find the deflection in the same direction. There will be no deflection in other direction, and if there will be no deflection in other direction, then how you will reach to the 0 value? Okay, so this is one of the source of error. Be careful. The first thing. Second thing. Okay, what are the sources of error? Actually, I am explaining over here. Okay, the second thing. Suppose phi is VAB by L. All right, the potential it is 10 volt and the length is 10 meter. Then for one length, how much potential you can measure? If you have given a battery of 1 volt, then very good, you can find out the value of E by doing experiment at how much? 1 meter. But what will happen if you are having a battery of very small amount? What will happen? If you are having a battery of suppose 0.05 volt, then what will be the length? Length will be very small. And as soon as you will put the jockey by moving very small length, you will find the null deflection, and it is very difficult to multiply this small amount. So what should we do? We should just decrease, okay, decrease the value of phi. And how you will decrease the value of phi? By increasing the length. So by increasing the length, as you will increase this length, this phi will drop down. Okay, you will increase the length. It means in very large distance, at very large distance, the small potential you will get. If over the 10 meter you are getting 10 volt, by increasing the 20 meter, again over the 20 meter you will get the 10 volt. It is quite obvious. So by increasing the length of potentiometer, you can increase the sensitivity. What does it mean by the sensitivity? Sensitivity, it means now this potentiometer can be used to measure the very small value, that is the very small EMF of the cell. This is called the sensitivity. So one method to increase the sensitivity, it is to increase the length. I hope you understand. Okay, now the question in board, it is asked why you use here a very high resistance. Okay, why you use here very high resistance? So I'm giving you the answer. This high resistance, suppose you applied a battery, you have given a driving potential. As soon as you will connect at this point, this galvanometer will give the maximum deflection. Maximum deflection, what does it mean? It means current is moving through the galvanometer. It might be the current will be so high and it can damage the galvanometer. That's why we use a high resistance. This high resistance will decrease the current, and this current, remember this current, it is moving not every point. At null point the current is to be 0. So at null point, whenever you will reach to the null point, you can withdraw this high resistance and it will not affect the balance point. Why? Because if current is 0, so the voltage not dropping over here, voltage will not drop even this high resistance also. If voltage is not dropping, so here 0, here will be also 0, after the high resistance 0, before the high resistance will be 0. It means this balance length will not change. Okay, so this type of question may be asked in board. In this way you can find the EMF. So what will be the value of E, my dear student? So the E is, this is a very important formula I'm writing, E is phi times X. Okay, the EMF here 0 0 0 0, here E at this point. So the potential drop across this length x can be measured by multiplying the potential gradient with the x. I hope it is very clear to everyone. So this was the first application. Now let we solve few questions on this first application, and then we'll move to the further topics. So the first question, student, this is the very important question. Remember the question. This is your potentiometer wire, battery, internal resistance, galvanometer, driving shell, okay, AB, galvanometer, this is the jockey, this is the balance length, EMF, internal resistance. Now the question, if driving shell having the potential 5 volt, listen carefully, and the length AB, suppose it is 10 meter, you have to find the value of E will be what? If X is suppose 1.5 meter. If at 1.5 meter you find Iz as 0, then what will be the value of E? Remember. Okay, try to solve. Okay, let me solve this question. First, what we have to do? We have to find the value of phi. And phi is the potential across this end. How much it is? 5 volt. Length is how much? It is 10 meter. So it is 0.5 volt per meter. And we know that E is nothing but phi times X. X is given, then E will be phi. It is 0.5 times X. It is 1.5 volt. Very simple. Okay. Now next question. Here, this is the potentiometer wire. Cell, internal resistance, galvanometer, this jockey, this is X, E, R, G, suppose it is 10 volt. Okay, now what are the given? What values are given? So you have given, now in this question you have to find the value of X. What will be the value of X? Suppose it is 10 volt. A resistance of this wire is also given. Suppose it is 10 ohm. You have to find X. This is suppose 2 volt. E is 2 volt. You have to find the value of X. Okay, try to find out. Could you find, my dear student? Yes. First, we have to find phi. How much it is? Potential across the end of the wire, it is 10 volt. So the 10 by length, how much it is? Length I have not given. Okay, suppose the length is 5 meter. Length of potentiometer is 5 meter. So it is 2 volt per meter. Now E is 5 times X. So E we have to find, sorry, E is given, E is how much? It is given 2 volt. So the phi is 2 times X. X will be 1 meter. At 1 meter from this end, galvanometer will show 0 deflection. Okay. Yes. Now the next one. The next question is very important. Now the concept of potential gradient is going to be changed, my dear students. Suppose like this one. This is the potentiometer wire, battery, internal resistance, galvanometer, jockey. point AB. Here with the battery a resistance is also connected. V, a resistance R, this small r, E. Okay, this is the point jockey, the balance length is X. Now, how you will solve such type of question? So in this question, first you should find out the phi, how you have to find the phi. Okay, so I'm giving you the answer. Suppose the resistance of this length is R0. This will be given. The resistance of this wire will be given. Don't worry. Alright. Now, as we have studied the potential difference across the end of the wire, potential difference across the end of the wire divided by the length of the wire is what? Phi. Length is suppose L. But here you can see the potential is not V only. If current is flowing in this circuit, as we know that current will not zero in this circuit. Current in this circuit we find to zero. If current is flowing in this circuit, if current is flowing in this direction I, then of course it will reach I over here also. And here the potential will drop. How much it is? IR. Suppose V dash. Okay, V dash. Then what will be the potential across this AB? Now VAB will be V minus V dash. And then phi will be V minus V dash divided by L. How you will find the V dash? Simply you try to find out the current. So the current is the total voltage of this circuit is how much? It is V divided by total resistance. Here resistance is R0. Okay, and another resistance is R. So it is R0 plus R. By multiplying this I with R, you will have the V dash. Okay, I times R, it will be V dash. Now you have the value of V dash and the V also. Then again you are successfully finding the value of phi. Okay, let me do a very simple question on the basis of this one. Look at here. This is the potentiometer wire. A battery is connected with a resistance. Suppose the 5 volt, 2 ohm. Alright. A battery, internal resistance, galvanometer. This is the jockey, balance length, ERG. Okay. It is 3.5 volts. Suppose E, this is the question. E is 3.5 volt. Then find value of X. What will be the value of X at null deflection? This is the point A, B. Okay. Length is, I'm not given length. Suppose length is 10 meter. Okay, length is 10 meter. Then you have to find the value of X. If the value of E is 3.5. If you can solve, try to solve this question. Okay, let me solve, my student. Here first duty to find the current. Okay, first duty to find the current. And the resistance, oh sorry, resistance I have not given of this wire AB. So resistance of this wire is suppose 3 ohm. Okay, now try to solve. The data was incomplete. The resistance of this one is 3 ohm. Now, so first we'll find the current in this circuit. So I can be written as the 5 by 3 plus 2. These two are connected in series. You can see if you just leave this circuit, you will find if it has the resistance 3 ohm. Okay, this whole wire having the resistance I have represented here. If it is 3 ohm, then you can see easily this 2R is connected in series. Why? Because current is not going in this branch now, so you can remove this branch and you can see this 3 and 2 are in series. The total resistance will be 5. So the 5 volt by 5, it is 1 ampere. Now how much voltage will drop over here? So here 3 volt will drop. How? 1 ampere current flowing. sorry, yes, 2 volts, sorry, 2 volt. 1 ampere current is flowing and the resistance is 2, so the 2 volt. Now, if 2 volt drop over here, what will the potential across the two end, that is the terminal voltage? So the VAB now it is 5 minus 2 and it is 3 volt. I hope everyone agree. Now over the 10 meter, what we are having? Over the 10 meter we can measure 3 volt, not more than that. Okay, we can measure below 3 volt, but maximum we can measure how much here? 3 volt. But we are having a cell 3.5 volt. It means if over this unit length you will divide, the total potential will be how much? It is 3 volt. Can you exceed 3? Can you find 3.5 volt in between these two? The answer is no. 3.5 will be beyond this B. So the answer is you cannot obtain, remember, we cannot obtain balance length over here. And a very interesting point you got. What interesting point? To obtain, in note point you will write, in note point, this type of question will be asked by the external. Whenever they will come to your lab, they will try to catch you, they will try to judge you whether you know particular concept to do the experiment or not. If you are using a battery eliminator and applying here 1.5 volt and here the battery you are applying 2 volt, remember the balance length will not obtain. So how you will just do the changes, you must remember. But the note point, which is the very important, the potential across the two end of the wire, okay, that is the VAB, potential drop across the end of the wire. You can also write this is the potential of the driving cell, but you can see not only the driving cell, because you have to study the net potential. So VAB should be greater, always greater than the EMF of the cell for which you are doing the experiment. That is the very, very important. Remember, my dear student, the potential drop across the end of the wire, potentiometer wire, should be greater than the EMF of the cell for which you are doing the experiment. That's why you are not able to find here the value of X. Okay. Now, I'm going to modify this question and then you will be able to solve this question. Okay. If in this question I use to write this E as 2 volt, could you find the value of X now? In this above question, okay, you have to write everything. Remember, if in this question I only change this E by 2 volt, then what will be the value of X? Now solve. Okay, let me solve this one. If you can solve, pause the video and try to solve this question. Okay, my dear student. So we know that E equals to 5 times X. Okay, we have to find the value of X, and E, it is 2 volt. Alright, divide by 5. So what was the 5 here? The 3 volt across AB. So the 5 is 3 by, how much the length it was? Actually 10 volt per meter. So it is 3 by 10 and it is how much? 20 by 3, that is 6.67 meter. Yes, on the 10 meter you can find the 6.67 meter exactly, but using this value 3, if you will calculate, you will find the value of X more than 10 meter. And how you will just move the jockey? If you are having only length 10 meter, then how you will find the value more than 10? Okay, yes. Now next question, my dear student. Here, one more question I'm giving you. Try to solve. Suppose this is your classwork. Suppose this is a potentiometer. This is much more interesting question. Potentiometer wire of length AB. A resistance is connected. This is 15 volt. This is the galvanometer, and the values I'm giving you. Suppose length AB, this is A, this is B. AB is 1 meter. Okay, resistance of this wire is suppose 10 ohm. All right, 10 ohm. All right, and here resistance is suppose 5 ohm, and this is X, 1.5 volt. Here the 1.2 ohm, 0.3 ohm. When this IZ is 0, the question, try to listen carefully. The question, you have to find the value of X, the length of this potentiometer. I have given all the data, it is given. You have to find the value of X. How you will solve this question? Try to solve by yourself. Pause the video and try to solve this question. Okay. Now let me solve. First, our duty to find the potential gradient. All right, potential gradient, and the potential across this two wire from the given cell. Here the cell is not a single cell. When current across this will be 0, look at here. When the current is 0 from here, the current will be 0 over here also, that is through the galvanometer. It means the current developed by this battery, listen carefully my dear student, the current developed by this battery, it will move only in this branch. Okay, and the current developed by this battery, it will move in this branch only. Alright, because at the condition where it reaches to the null deflection, in this case I will be 0. So here the potential, as we used to write just connect one battery, but here the battery and resistance is also given. Might be in question, it will be given the battery with a internal resistance. Okay, so try to find out the voltage. But one thing which is very important, look at here, potential across this 2 point and potential across this 2 point will be what? Same, because these two are parallel. All right, so try to find out first the current. As soon as you will find the current, by multiplying this resistance with the current, you will be able to find the EMF, and this EMF is equals to the EMF across this length X. Okay, so the current over here, it is I is equals to 1.5 divided by the total resistance, it is 1.5 plus 0.3, it is 1.5, that is 1 ampere. So what will be the potential? Suppose it is the point P and this is the point Q. So what will the potential difference across here? Here the current is moving 1 ampere. So the VPQ, which is the E, it is equals to 0.3 volt. Okay, multiplying this 1 with the 0.3, you will get the 0.3. So first we have calculated here E. Now rest are the very same as we have solved. The rest question you have to solve this one also. Try to find out the current in this network to find the phi. Alright, so the current in this network will write by I dash, because we have written here I already. So I dash, let I dash. So here I dash is nothing but the 15, that is the total potential, divided by resistance of this circuit. Here the 10 ohm and here 5. It is 15 by 15. It is 1 ampere. Now VAB, okay, the potential across the end, across the potentiometer wire, it is VAB. It is how much? The voltage over here you can see 15 minus how much potential drop here? 5 volt. So 15 minus 5, it is 10, divided by length of the wire. It was how much? It is 1 meter. So it is 10 volt per meter. I hope you understand. Now we know the formula. What is it? The formula is E is equals to phi times X, and we have to find the value of X. So X is E, and E how much? 0.3 divided by phi. We have calculated phi how much? It is 10. Yes, it was VAB only, na? Yes, so the phi we have not written. Actually the phi is VAB divided by L, which is 10. Alright, so it is 10 and 0.03 meter, that is 3 centimeter. And okay, my dear student, so in this way you can solve any question of potentiometer. In next class we will do few more applications of potentiometer, that is how to compare the EMF of two cell, how to find internal resistance of any cell. Okay, so with this particular numerical we are concluding today's lecture, my dear students. Thank you very much.